Bismillahirrahmanirrahim. In this session, we will discuss the rate of change on a speed time graph, and this is some of the examples. And in exercise 24.4, we will learn all these things. Some speed and time graphs. On this axis we have speed, and on the horizontal axis we have given time, and we have to calculate the acceleration. So change in speed divided by change in time. So change in speed in a given time, or change in time gives the acceleration. So we'll find this acceleration. Similarly for this, calculate the deceleration, because the speed is decreasing, so this is deceleration, and from this speed and time graph. So we will learn all these things. So similarly for this third graph, so let's start 24.4. so we have this speed is 0 to 6 meters per second, and this is 0 to 8 seconds. So the final speed is 6 and initial is 0. So 6 minus 0 is the speed change in speed, and distance the time is from 0 to 8. So 8 minus 0 is here. So this is 6 upon 8, and this is in meters per second, and this is in seconds, so it is meters per second square. So 6 upon 8 is 0.75 meters per second square. So the acceleration is this acceleration is equal to 0.75 meters per second square. Similarly for this problem, we have the initial speed is 4 and the final speed is 10. So the change in speed is 6, and time taken is 0 to 15. So 15 minus 0, 10 minus 6, 4 is 6, and this 15 minus 0 is 15. 6 upon 15, that is 0.4 meters per second square. So this is meters per second, and this is seconds. So meters per second divided by second is 0.4 meters per second square. So second problem, here we have the deceleration in meters per second for each of these speeds. So this is 9, and it reaches to the rest position 0 velocity in 0 to 15 seconds. So this is 0 to 9, and this is 15 minus 0. 15 minus 0, 0. This is the final speed. This is the initial speed. Initial speed was 9 meters per second. Final speed is 0. 0 minus 9 divided by 15 minus 0. So 9 upon 15, that is minus 3 upon 5, that is minus 0.6 meters per second square. So this is decelerating. And similarly for this, 18 to 14. So 14 is the final speed, 18 is the initial speed. At t is equal to 0, at t is equal to 16, the speed is 14. So this is negative speed is decreasing. So 14 minus 18 is minus 4, 16 minus 0 is 16, 4 upon 16 is 1 upon 4, that is minus 0.25 meters per second. So this is deceleration, because negative sign is showing that the velocity is decreasing. In this graph, we use the graph to estimate the acceleration of each object when t is equal to 5. So this is easy. So at t is equal to 5, we can have to place a tangent, and we can change in speed and time can be calculated. So this is easy. So this is part 4, and part 4 is here. This is the speed time graph for a car journey, and the calculate the acceleration in meters per second square for each stage of the journey. So it took from here to here, and then it speed increases, and then it stays there with a constant speed. It takes a constant speed and then deceleration. So for this we have this one step, second step, and third step, and then final fourth step. So from 0 to 30 seconds. For 0 to 30 seconds, it took 0 to 10 seconds. So the speed was increased from 0 to 10. So the speed increases. Final speed is 10. initial speed is 0, so this is 10 minus 0, and the initial time was 0 and the final time is 30, so that is 30 minus 0, so 10 upon 30 is equal to 0.33 meters per second for the duration of 0 to 30 seconds. For 0 to 30 seconds, the acceleration was 0.33 meters per second square, and in the phase 30 to approximately 45 or sorry 30 to 45, so this is 30 and this is 45. For this 30 to 45 we have this 10 to 20, so this is 10, at this point this is 10 and this is 20, so the initial speed was 10 at this time, 30, and at 45 its speed was 20 meters per second. So the change in speed from 10 to 20, so 20 minus 10, and the time duration is 45 minus 30, so that is 15 seconds. So 10 upon 15, 2 upon 3 is 0.66 meters per second for the duration of 30 to 45 seconds. And from this 45 to this 65 or 65, I think it's 65. It can be read easily from here. Yes, it is 65. So for this duration 65, we have this 0 to 20, so sorry, this time the initial speed was 20 and the final speed was 20, so the difference is 0, so the acceleration is 0 divided by this duration, so the result is 0. So 45 to 65, the acceleration is 0. In the last stage from 65 to 90, so from 65 to 90 we have 0 to minus 20, so this is final speed is 0, initial speed is 20 meters per second. So the difference is 65 to 90, so 90 minus 65, and here we have this negative sign showing that the speed is decreasing, so 20 upon 25 is minus 0.8 meters per second for the duration from 65 to 90. So acceleration is for this duration is this. And similarly for this B part, we have A is equal to V upon T. Calculate the speed of the car when T is equal to 20. When T is equal to 20, it was within this duration, so that is again speed was 6.67. At this 20, this speed, acceleration is multiplied by time to give the speed. At this time the speed was this. Similarly at T is equal to 75, the speed was this. In the next section we will discuss this question number 5 and 6.